Okay, so in this problem, we're asked to take the derivative of x raised to the power negative 6x. And most people are thinking that maybe they should use the power rule, but that power rule, so let me write that power rule, d dx of x to the n, that power rule is only good when the power is a number. All right, here, our power is not a number. So what we're going to do is we're going to use a trick. All right, so let's write this problem as f of x. So f of x equals x raised to the power negative 6x. And our goal is to get f prime of x. So a trick when you've got an x upstairs in a power is to take the log on both sides. And a lot of times you can either use ln or log. I like to use ln because the derivative of ln is just du over u, right? So the derivative of natural log is simpler than trying to take the derivative of an log function. So we're going to use ln here. So I'm going to take what I've got and I'm going to apply the natural log on both sides. And the reason I do this is because now that power comes downstairs out front. So let's rewrite our problem. We have natural log of f of x equals negative 6x times the natural log of x. So now the good news is I don't have any more x's upstairs in the power, but I still have to take a derivative, right? I haven't done any derivativing at all. So let's take the derivative. Now both sides are going to use different rules. So let's look at the right-hand side over here, right? So we're going to take the derivative of both sides. So we can write this as like d dx and then d dx. And on this right-hand side, I'm going to have to use the product rule. That's a product. So we'll do our f as negative 6x and our g as natural log x. So f prime would be negative 6 and g prime would be 1 over x. Now this f is not related to the f in the problem, it's just the shorthand. So whichever notation, whichever notation you use, some people use a and b, but normally I just use f and g. So the f that I just wrote is not related to the f from the original problem. Okay, sorry, I had to relocate. So now, let's apply our product rule. Our product rule is fig plus gif, if that makes sense to you. F prime g plus g prime f. So on this right-hand side, the derivative is going to become f prime g, so negative 6 times the natural log of x plus g prime f. So that's 1 over x times negative 6x. And that simplifies, right? Just this, the x's cancel on top and bottom. So on the right-hand side, I have negative 6 times the natural log of x, and then minus 6. Excuse me. So I've taken the derivative of the right-hand side. Now let's take the derivative of the left-hand side. So this left-hand side is natural log of a function. and this is a function of x. And since we're taking the derivative with respect to x, we're going to have to use the chain rule. When we have natural log of u and we want to take its derivative, that becomes du over u, right? Du with respect to x. So here, our u is f of x. So our du would be f prime of x. So my left-hand side, when I take its derivative, will be du over u. So my left-hand side becomes f prime of x over f of x. Right, so this derivative here became this guy here, and this derivative here became this guy here. So I got a lot of colors. I'm going to go back to black. I'm going to write this equation out. So I've got f prime of x divided by f of x, and that equals -6 times the natural log of x, subtract 6. Now what was my goal? Remember, my goal up here was just f prime of x. So to get f prime of x alone, I have to multiply by f of x on both sides. So I'm going to times both sides by f of x. Right? It would cancel on this side. So on my left-hand side, I have f prime of x equals -6 natural log of x minus 6 times f of x. But what in the world was f of x? Oh, we have to go all the way back, right? We decided that f of x was equal to x raised to the power -6x. So instead of writing f of x here, we're going to write x to the power -6x. So my last step, I have f prime of x equals -6 natural log of x, subtract 6 times x raised to the power -6x. So the next problem we're going to do is also a derivative problem. I've got the function y equals secant x plus tangent x, and then whole thing raised to the 20th power. So this one is just a power rule, right? So we're thinking about the rule. If I wanted to take the derivative with respect to x of x to a power, we have to bring the power down and then bring the power down. So we bring this power downstairs out front, so n times, and then we bring it down by subtracting 1, so n to the -1. But the thing is, if the thing that we're raising to the power n, as some number, is not just x, then we also have to times by its derivative. So the way that we would write that, d dx of u to the power n, so u is some function of x, we'd still use the bring down rule, right? Bring down the number, and then bring down the power. But now, since that wasn't just x, we then have to times by the derivative of that. We could call that du dx, you could call it u prime, you could call it just du if you understand that it's with respect to x. And that's the chain rule version of the power rule. So in this problem that we have, we've got something raised to the power 20. So my u in this case is secant x plus tangent x. And my du with respect to x, so the derivative of secant is secant tangent. So secant x times tangent x. And then the derivative of tangent is secant squared. So plus secant squared of x. Okay, so now let's go back to our problem and we'll do it in u's first. So y equals u to the 20th. So if I want to find y prime, right, so I do d dx, d dx. I have to bring the 20 down and then bring the 20 down in power to 19. But since that wasn't just an x, it was a u, I have to times by the derivative of that thing with respect to x. Okay, but I know what my u and my du are, right? My u was secant plus tangent, and my du was secant tangent plus secant squared. And so I can just basically go back to x's. So I have 20, and then secant x plus tangent x raised to the 19 times the derivative of secant plus tangent. So I'm going to times this by secant x tangent x plus secant squared x. And that's going to be y prime, or dy dx.